Assalamualaikum warahmatullahi wabarakatuh, Miss Ita. This video will present about food and non-food production. We are from Group 7. My name is Anisofia binti Suliman, and the rest of my group mate is Hanitsah binti Muhammad Jaafar, Nurul Najihah binti Satar, and Nur Syahira Amila binti Roslan. We have divided into 2% per topic, while me and Hanisa take food production, while Najihah and Syahira take non-food production. This is table of content. First is history of margarine. Second is butter versus margarine. Third is preparation of margarine. Fourth is equipment used, and the last one is manufacturing process of margarine. History of margarine production. The history of this margarine began in France, and it was invented by the chemist that is Hippolyte Marie in fulfilling the request of Emperor Napoleon III to produce a cheap butter that's called oleomargarine for his soldiers in the Franco-Prussian War. In 1869, the first margarine was produced from beef mixed with the milk, due to having very limited beef stock. Later on, the oleomargarine was shortened to margarine. Wilhelm Norman from Germany in 1902 has produced a process to solid fat by the process of hydrogenation. This has made the vegetable oil market widening and has a long-lasting margarine stock. In the early 1980s, margarine contained trans fat and did not include animal fats or other saturated fats oil. This is because the oil that contains trans fat can save. Margarine is a type of fat spread in the form of water and oil emulsion, where the water phase is finely distributed as droplets in the continuous feed phase. Margarine contains a combination of 80% of vegetable oil, 20% of water, added salt, emulsifier such as lecithin, flavor and color, as well as preservative, and also jumps and thickeners. This margarine has three types. First, for a cook or top dishes. Second, soft vegetable fat spreads. Last one is hard margarine, and it is for cooking and baking. Next is equipment used. First is water phase tank. Place for quality water only, and it is often prepared in the tank, but if the water is not in good quality, we need to use the filter system to the water as pre-treatment. Next is for agitated tank. In the water phase also consists the salt, preservatives, milk, and also flavors. All of them is filled in the agitated tank, then all of them will blend together in another tank. Next is fat phase tank, which is a tank that contains vegetable oils, and tanks that contain fats according to the recipe and texture that has been desired to produce the best product. The oil will treated first with caustic soda solution to remove the unnecessary components. Fat phase also consists the emulsifier, lecithin, coloring, and antioxidants, which are all of the ingredients will be mixed into a mixer and dissolved with a mixture of oil and fats. A mixture of fats and oils is inserted into both of emulsification tanks according to the highest melting point first, then insert followed by the lower melting point. Then all the ingredients of the water phase are added to the emulsion tank. After the ingredients of the fat phase are finely mixed to be mixed with the fat phase, the water tank and fat fish tank are very important to prepare the emulsion in order to be able to continually operate the crystallization line. At this point, it should put the alarm, because if the parameter work out of the limit that the actual value, it can inform the operator about it. For example, the water is over inserted into the tank, so the alarm will inform the operator about the out limit. Next is holding tube. It is used for placing the warm emulsion, and the emulsion will crystallize in the tube, and it will be semi-solid state because the water and the liquid oil becomes droplets in the emulsion. The emulsion is cooled by vaporizing ammonia refrigerant in the jackets of the heat exchanger that known as rotator within 5 to 10 seconds, and then the emulsion will transfer to the scrap surface heat exchanger SSHE. The SSHE actually is for pre-cooling, supercooling, and generally used in cooling the crystallization. Next is the pasteurization process is intended to inhibit the growth of microorganisms such as bacteria by using high pressure scrap surface heat exchanger SSHE. The last part is the modern plant should put cleaning in place, which is CIP, if they want to facilitate their work to clean the tank after they use them, especially for the fat tanks and emulsion tank.
Margarine manufacturing consists of 6 steps. First, preparation of blend. Second, hydrogenation of the plant oil. Third, emulsification. Fourth, chiller. Fifth, crystallization. And lastly is a packaging. First, preparation of blend. As you can see, this is the table for percentage we need for making a margarine. First, edible oil consists of palm oil, olive oil, sunflower oil, and soybean oil. We need 82%. Second, water or skim milk, 60%. Third, distilled monoglyceride or DMG, 0.3%. Fourth, soya lecithin, 0.2%. And lastly, salt, 2.5%. The second step with hydrogenation of the plant oil. The definition of the hydrogenation is to treat oil with hydrogen and catalyst to decrease double bond and increase saturated bond. Hydrogenated vegetable oil is made from edible oil extracted from plants such as olive, sunflower, and soybean. The vegetable oil reacted with hydrogen gas at about 60 degrees Celsius. The double bonds are converted into a single bond in this reaction. This process turns the oil into semi-solid using a batch autoclave and pressurized using hydrogen and catalyst. Usually we use supported nickel catalyst. This process forms trans fat, which is not good for your health. The palm oil do not require hydrogenation because oil is naturally thick and does not have trans fat. The third step, which is emulsification. Emulsification consists of 2 immiscible liquids, which are oil and water, with one of the liquid dispersed as small spherical droplets in the others. There are 2 types of emulsification, which is water in oil and oil in water. For the margarine manufacturing, we use water in oil. There are several steps in this process. The first one, oil is mixed in continuous stirring mixing vessel at 60 degrees Celsius to 70 degrees Celsius. Second step, we add in the salt and water soluble ingredient. The mixture of the aqueous phase, which is water or milk, depending on the type of margarine. The third step, we incorporating emulsifier using lecithin to reduce surface tension between oil and water. Emulsifier need to be dissolved in the small volume of the oil and fat blend, preferably ratio which is 1:4, before incorporated in the main body of the oil in the tank. The soybean egg yolk is one commonly emulsification agent used in the margarine manufacturing. And the last step, we added the remaining ingredients such as antioxidant, flavor, color, and vitamin. Vitamin need to be added at the last because it tends to be destroyed by agitation. Okay, the mixture are moved into the next process, which is chiller. The cooling are done in a scrub surface heat exchanger, or known as SSHE, such as voltator, using suitable low temperature. We use 50 degrees Celsius to 7 degrees Celsius. The cooling medium or cooling agent, we use evaporating liquid ammonia. The tubes are provided with rotating blades. The emulsion and the cooling fluid are moved in relation to each other at the same direction. The rotator shaft has high rotation speed. This process, also known as a pre-crystallizer, to create plasticity of margarine. The next step, which is crystallization. The crystallization gives best result of good consistency and smooth texture of margarine. The cool fat then passed into a crystallized equipped with rotor, where rotor operating at high speed. We're using lower temperature to give more crystallized and thickened result. The degree of crystallization depends on resident times and the rotational speed of the shaft. And the last step in margarine manufacturing, which is packaging, we collect the margarine from pin worker in control condition before distribution. There are types of package, which is bricks, plastic tubs, plastic container, carton package, and secondary package. The process flow diagram for margarine production. The storage tank for oil phase usually grouped in a tank farm laid out for convenient access and efficient piping. We go through weighing system. The oil phase consists of 80% of blend of different fats and oil, such as edible vegetable oil, are stored into oil storage. These are kept stable storage temperature above the melting point of the fat and under agitation in order to avoid fractionation. The oil and oil-soluble ingredient with blending and weighing. For the cultural tank, they must undergo preparatory measure before go through mixture tank, and the blending and weighing 20% of milk, salt, emulsifying agent. They also undergo pasteurization to remove impurity. Okay, the oil and liquid phase will be mixing in the emulsion tank. This system using dosing pumps and mass flow meter to control the ratio of the added phases into a small emulsion tank. The mixer is equipped with variable speed drive to reduce the speed for agitation after emulsification is done. The pump then forward into the emulsion to the voltator supply tank. The voltator divided into two sections, which is voltator A unit and voltator B unit, using high-speed pump. The voltator unit A consists of a steel shaft which rotates in a tube. The tube is cooled externally by liquid ammonia, and the rotator shaft is equipped with scraper blades that rub against the cool inner surface at high rotation speed. The high internal pressure and the chilling action cause the nucleation or crystallization of the margarine. Usually the operation is at 50 degrees Celsius to 7 degrees Celsius. Next, the crystallized blend will work into a second agitation without additional cooling at voltator B unit. The voltator B unit promotes triglyceride crystal growth with the shortening while working the shortening to form uniform crystal size that pourable and not too solid. The unit consists of a larger diameter tube having stator pin in the cylinder wall and rotating shaft fit with rotor pin. And the last step in this process, the margarine then will be packing and filling. The product which are packed using paper wrap must exhibit a firmer texture and consistency than a product which is filled in containers. And margarine is ready for distribution for loading platform.
So today I will explain about the non-food production, which is soap that we choose. And soap can be defined as a substance that can be mixed with water and also can use as cleaning and washing. So soap is the compound that made of natural oil such as palm kernel oil, coconut oil, and mix of fats such as tallow from beef or mutton or beef blend. In the soap making, there are compound is made with the strong alkali. For example, the alkali is sodium hydroxide, NaO, or potassium hydroxide, KOH. And the manufacturer industry just bought a solution that contains wood ash and animal fat, which is the evidence recorded by the in ancient Babylon in around 2800 BC. And they use that containers that to mix the wood, ash and animal fat, and the foam substance is formed at the top. When it cooled, it hardened into soap. So here I attach the chemical reaction of the soap. Soap has many kind of purpose, which when we dissolve in a water to be used, it breaks dirt away from surface, and it can use as a cleanse, cure skin, cure soles, to dye hair, and also salve or skin ointment. But generally today, soap is used as cleanser or perfume. So the difference between soap and detergent are, for the soap, it made from natural ingredient, which is oil, palm oil or coconut oil, which is mixed with the alkali. And detergent is synthetics of man-made derivative. Soap is biodegradable, while detergent not really degradable. Soap only for soft water, and detergent are suitable for both and hard water. The equipment used in the soap production are, first one is storage tank. Storage tank is the container that can fill the liquid in compressed cases or medium use for a long time or short storage of heat or cold. And storage tank also can function as a reservoir and manufacture containers. And the storage tank usually made from steel, concrete, or also the fiberglass. And it is because in storage tank usually use this kind of material because they need to store a chemical before they start the process. Next is a blender, which is the blender is used to create liquids, which is they mix in the blender itself. And in the industry of soap production, factory use large tank capable to mix large amount of mixture. And the common blender used is ribbon. It could be ribbon, exploder, and anything. And the blender is made from mud and stainless steel in order to hold and avoid from leakage. The third one is a filter. Filter is the process of separating the foreign solid matter from a liquid by making it pass through the pores of some substance, which is in the soap production itself. Not usually, it's kind of use plate and frame filter because it's easy to filter the solid and liquid mixture. And the example also there are many examples of filter, which is a plate and frame filter press, fully automatic filter press, resist plate filter press, and also membrane filter press. And most common materials to make filter is polypropylene, and the polypropylene also could be made from polymers or steel coated with polymer. The third one is a filter. Filter is the process of separating the foreign solid matter from a liquid by making it pass through the pores of some substance, which is in the soap production itself. Not usually, it's kind of use plate and frame filter because it's easy to filter the solid and liquid mixture. And the example also there are many examples of filter, which is a plate and frame filter press, fully automatic filter press, resist plate filter press, and also membrane filter press. And most common materials to make filter is polypropylene, and the polypropylene also could be made from polymers or steel coated with polymer. Heater also used in this soap production. Heater is cylindrical vessel that also known as heat exchanger. And a heat exchanger is also kind of type of shell and tube that operate to transfer heat between two different fluids, which is hot and cold. And the heat exchanger usually used for cooling and heating process, and to prevent the mixing, the fluids may be separated by the solid wall. Dryer used as a function to dry and solidify the soap. The process will be able to remove the moisture from the soap. And the type of dryer is fluidized bed dryers, rotary dryers, rolling bed, conduction, convection, pharmaceutical suspension and paste dryer, store bed, and also dispersion. And the equipment is useful for drying and suitable for drying materials that had heat sensitive. And the stainless steel dryer and alloy used to make dryer because it has higher durability to hold the dryer when the drying process happens. Plodder is another important equipment in order to produce soap because it can use for extrude the final soap before cutting it into variety soap. And the extruder of the plodder were made from stainless steel pipe and aluminium alloy screw that have been rotated inside the pipe. The reason why this material used is because to hold the heater, to hold the plodder and to hold heater and the temperature sensor that have in the plodder. The example of plodder that frequently used in industry is duplex vacuum plodder. The cutter function actually to cut the soap that already finished that come out from the plodder. Many categories of soap cutting machines such as air power soap cutter, manual soap cutter, loaf soap cutter, and others. And the cutter's machine is made from the stainless steel and also have a sharp knives to cut the soap evenly before it gets to packaging and so on. Last but not least, before the soap is getting sold to the market, another important thing is stamping. Stamping can do it manually or using automatic soap stamping. And automatic soap stamping a machine frequently used in a big production company because it can save more time and can do more soap stamping at one time. And a soap stamping machine is made from stainless steel because it's strong and steady to accommodate with many soap at one time. And usually the small company use the manually. It could be use the labor supply that need to stamp all the soap.
So this is the other equipment that were used in the process, which is boiler water feed, bleacher tank feed pump, span live feed pump, dry soap pump, finisher, and soap dryer. Now I will talk about the process description of the production of the. So there are three major types of saponification process. The first one is a full boil kettle process, cold process saponification, and semi-boiled process. These the three types process have such a different way to produce the soap. Except the second and third one is kind of similar but different for the temperature. So between the three process, it shows that the full boil kettle process is better than other process for the commercial purpose. For example, full boil kettle process had been chosen to produce the toilet soap. This is the PNID diagram for the production. The production of the soap consists three different sections, which is first crude soap, manufacturing section, first glycerin recovery, third soap finishing and packing process. For section 1, we have 6 different steps, which is 1. Oil weighting, blending and bleaching, 2. Saponification, 3. Washing, 4. Soap base cleansing. The next step is soap drying and stock fan and SFP. So the process started with oil weighting, blending and bleaching. The oil is wet and blended in an open time. There are more to bleaching. There are a few processes done here, which is vacuum bleaching and free moisture. The second step is saponification process. The feedstock is charged in a kettle type pan and caustic soda is also added. It is to make the saponification process to started. The process is extremely slow, so heat will be applied in form of saturated steam, which is at about 3 bar to boil the reactants. The next step is washing. There are 3 additives that are added into this process. It is caustic soda, water, and brine solution. All of these were fed into a batch fitting and settling tank which contain crude soap and Ligia solution. The fourth step is soap base cleansing.
This is a process where the soap will be settled into 3 layers, which is called as aerated soap, neat soap, and high electrolyte soap. The fifth step is soap drying. For this process, it starts with heating the soap in heat exchanger. The first and second column is connected to each other. During this process, saturated steam will be used as heating medium. Soap is also heated until it reaches 140 degrees Celsius for drying section. Getting out from the heat exchanger, the soap then fed into screw-type dryer using a nozzle. Soap is blown from top to bottom. The final product of the soap will have 140 degrees Celsius for the hot soap and 40 degrees Celsius for the dried soap. The last process of this step is stock fan and SFD. The dried soap then will go through some mixer to add more additive and other substance before the finishing product is done. So the section 2 contains glycerin production section, which the first step started with first treatment filter press, second treatment filter press, double effect evaporator, finisher, still wetting, drum filling and warehousing. So this is the PNID diagram for the section 2. Glycerin is a byproduct from this whole process, and at the end of this process, we will send the glycerin for pharmaceutical industry use.
That's all from us. Thank you for your time and watching this video.